Hello everyone, welcome to Mobile Maths with Kamchira. I want us to look at a revision test for the form ones that I gave you guys. Okay, so our first question was saying correct that number 99.987 to one decimal place. Okay, so this is 1 dp. Okay, so what we do when they say one decimal place, it means, let me write the number, 99.987. It means we are going to go to our first digit after the decimal. That's the decimal 1 dp there. Okay, now we go there. After going to that number 9, we go to the next one and check, is it a number that is 5 and above? 5, 6, 7, 8, 9. Okay, so if it is any of this number, it means we are going to round off our 9 to the next number. Okay, so in this case, since we have got 9, if we round it off and we have our number next, which is 8, so 8, we can round up our number, this number 9, and if we round it up, it becomes 10. So when it becomes 10, it means I'll have a 0 here, and here I'll have a remainder 1. 9 plus 1, I'll have a 0 again. Then here, 9 plus 1, I'll have a 10. Okay, so this becomes our answer. And it is to one decimal place because we've got a decimal place there. Now, let's look at the second part of the question. This was part A. Let's look at part B of the question. Part B of the question is asking us to correct our number to one significant figure. Okay, let me write it. Our number is 99.987. We want to correct it to one SF, one significant figure. Okay, so when they say one significant figure, what we do, we go to our first number, that's one SF there. First number is 9. Then we look at the second number, which is our 9 there. Is it a number that is 5 and above, like on the previous question? If it is above that, we have to round to the nearest number. So if we round 9 to the nearest number, it becomes 10. So when it becomes 10, it means I'll write and have 0 there. I'll have 10, then 9 plus 1 here, I'll get a 10. Okay, so this is how we round off, and we have this one to 1 SF. Okay, let's go on to number C. Number C is asking us to write in standard form. Okay, part C is saying standard form. So we have our standard form as A times 10 to the power of n. Okay, so 99.987 in standard form becomes 9.999 times 10 to the power of 1. Okay, so that's how we write it in standard form. Okay, where am I coming from? Let me write it. We had 9.987. Okay, because here we've got 2 digits, that's where I'm taking this 10 here. Then we change our comma, going this way, it becomes a positive 1, that's why I have 1 there. Then I write everything. I've got 9, 9, 9. Then this 8 here, the last 8, this one, I will change it, taking this 7 and rounding it off to the nearest number, which is 9. That's why I have 9999 there. Okay, let's go to the next number. Okay, so this number is asking us of rational numbers. So a rational number is any number that can be written as a fraction where both the numerator and the denominator are integers. Okay, and the denominator is not equal to 0. Okay, so automatically from that statement, it means 17 over 19 is a rational number. Then we also have a situation where all decimals that can terminate or that can end are also uh, rational numbers. So I have 3.1 is another rational number and 0.3 is a rational number. Someone may ask me, what about pi? Pi is 22/7. If you divide 22/7, you get 3.1415. The number goes on and on. That's the number that does not end or that does not terminate. So automatically this becomes an irrational number. Okay. Then all numbers under square root signs, 3 and our square root of 169 there, they are also okay. That's how you answer that question number 3. Okay, part A was asking us to express 108 as the product of its prime factors. Okay, so what I'm going to do here, I'll just divide A. I'm going to divide 108 divided by, I'll start with the lowest prime factor. I've got 2, 2 into 10, 5, 2 into 8, there, 4. Okay, then let's go on. The next one, I've got 2 can also go again into 54, 2 into 5, 2 remainder 1 into 14, 7. Okay, fine. Then the next one, I also have 2, and now I can have 3, sorry. 3 into 27, it goes 3 times 9. Okay, 3 into 27, it goes in 9 times. Then again, I can take 3 into 9, I get a 3 there. So I'm dividing up until I get a 0. 3 into 3 there, it gets 1 time there. Okay, so basically I've divided everything. So it means the prime factors for 108 are, I have 2 times 2 times 3 times 3 times 3. Okay, then writing them properly, I've got 2. How many 2's? I've got 2. So I say 2 times 2 to the power of 2 times. Then for the 3's, I've got 3. 1, 2, 3. 3 to the power of 3. So these are the prime factors for that question. Let's go on to the question number 2. Question number 2 was asking us to find lowest common multiples for these 3 numbers. So I've got 12. So I'm going to find common factors for each number using those prime numbers that we just did. So for 12, I've got 2 times 2 times 3. Okay. 2 times 2, I get 4. 4 times 3, I get 12. Okay, fine. Let's go for 18. 18, I will get 2 times 2. Okay. I'm simply dividing there. Let me do it. 18 there divided by 2. 9. Okay, so here I should have a 3 there. 3 into 9, 3, 3 there. Okay, fine. So I've got 2 times 3 times 3. Then for 24, I do the same. 24 divided by, I go with 2, 1, 2, 2 again. It goes there and leaves 2 into 6, 2 there. It goes 3, 3, 1. Okay, fine. So the factors there, prime factors there, I've got 2 times 2 times 2 times 3. Okay. Now, having all of that, for me now to write my LCM, my lowest common multiple, it's going to be, the LCM for those 3 is going to be, I take all the 2's that I have and write them. How many 2's do I have? These are the 24 has got more 2, so I write them as it's there. 2 times 2 times 2. There are 3 there. Then for 3's, here I've got 1, here I've got 1, and here I've got 2, so I'll write 3. 2 times 3 times 3. Okay. So at the end of the day, my lowest common multiple for this one is going to be this one. Let me do it. Let me write it now. Okay. So I'll have at the end of the day 2 to the power of 3 times 3 to the power of 2. Okay, this is in terms of factors, and if you want to have it as a number, you can simply multiply and get the number. So if we multiply 2 times 2, 2 times 2, we get 4 times 2, 2 times 2 times 2 times 3 times 3, we get 72. So at the end of the day, this is basically is the same as 72 there. Okay, so this is the same as 72. Okay, so either answers could be correct there. Okay, let's go on to the other question. This one is asking us to write 75% as a common fraction. So 75, since it's a percentage, it means it's something that is over 100. So we say 75 over 100. So this one I can divide by 25 over 25 there. So if I divide by 25 over 25, I'll have 75 over 100 by 25 over 25. So that I divide them. 25 there, 4, 25 there, 3. So at the end of the day, my fraction, which is lowest, is going to be 3 over 4. Okay, let's go on to the next question. Okay, this one is asking us to express 27.1 correct to 1 SF. Remember, we said when we are talking of 1 SF, 27.1, 1 SF, we look at the first digit because it's 1 SF. Okay, 1 SF. Okay, so then I consider the second digit. Is it 5 and above? So I can go forward and I can change my 2 to be 3. So this is going to be equal to 30. This is to 1 significant figure there. That's the answer. Our answer is 30 there. Okay, when we are talking to about 1 significant figure. Let's go on to the next question. This question is asking us to estimate this value after rounding off each number according to 1 significant figure. So we are going to round these numbers according to 1 SF there. So if I round them, I'm going to have 7.63. I look at 7, the next number is 6, so I can have an 8 there, times 5 point, the next number is 8, so I can have a 6 there, times this one, I've got a 3 here, so I'm rounding down, so I can have a 9, over 27.1, this is 1 there, I can round down, so I have 27, times 31 over 31.2, this is small, so I can have 31 there. So this is what I have at the end of the day. So having this number, I can divide, I can simplify it. 9 there can go into 27.3. Okay, now I have this fraction. It's now 8 times 6 over 3 times 31. Okay, simplifying that, 8 times 8, what do we get? I can get 16. Sorry, I think okay. 8 times, sorry, let me do that again. I think I missed something there. Let me go back. Okay, fine. That's fine. That's correct. Okay, I can even further divide this one. 3 can go into 6 2 times there. Okay, like that. Now let's simplify. 8 times 2, what do we get? I get 16 over 31. So this can be the final answer, or else you can divide and you get 0.5161 and so on. It's still fine and correct. Let's go on to question number 5. Okay, this one is asking us to evaluate giving our answers in the lowest terms. Okay, so for the first question, 4 over 5 minus 9 over 10. Our common denominator there is 10. So I'll have 5 into 10 is 2 times 4. Okay, then minus 10 into 10, 1. So I have 1 times 9 there. Okay, let's go on. So 2 times 4, what do we get? 8 minus 9 over 10. Fine. Let's finish off. Then 8 minus 9, I get minus 1 over 10. So this becomes the answer for that part. Let's go on to the next question. I'm going to use a different color. For part B, we have got 7 over 15 times 3 over 8. Then we have got a division sign there. When we have a division sign, we invert. And when we invert, it means we are now adding a multiplication sign, and our 7 over 8 becomes 8 over 7. So I'll write times 8 over 7 and divide numbers which can be divided together. 8 can go into 8 there, 3, 1 into this one, 5 times 7 can go into 7. Then at the end of the day, I've got myself, I have the answer is 1 over 5. This is the final answer there. Okay, let's go on to the next question. Number 6. The first part of the question is asking us to express 5 times 10 to the power of minus 5 as an ordinary form. So we are writing it in terms of commas there. Okay, so I'll write for the first one, it becomes, I'll have 0 point. So because I've got negative, it means I have 0 point something. Okay, so I have 0, 0, 0, 0. I now have 4 zeros, meaning to say for my comma there, which is 5, I'm going 1, 2, 3, 4. So it means I have to go another one, and I'll write a 5 instead of a 0. So I have a 5 there, such that if I count my minus 5 there, I have minus 1, minus 2, minus 3, minus 4, minus 5. So basically our answer becomes 0 point, our final answer is 0.00005 with 4 zeros there, such that if you want to go back, you simply count the number of commas 1, 2, 3, 4, 5. Okay, so that's how we do it. Let's go on to the next question. Okay, the next question is asking, we are given A as that and B as that. So we want to find A, B, and A divided by B. Okay, so A times B is equal to 4 times 10 to the power of 4 times 5 times 10 to the power of minus 2 there. Okay, so what do you do when you have such a question? You take these numbers, which are our A's, if we are looking at A times 10 to the power of n standard form. You take these ones on their own. Okay, let's do that. So I'll have 4 times 5. Those are the A's. Then times, I'm taking now these tens. 10 to the power of 4 times 10 to the power of minus 2, like that. Now let's solve. So for the first one, I've got myself 4 times 5, I'll get a 20. Then times, these ones have got same base, so I'll add the powers. So I have 10 to the power of 4 plus minus 2 there. Okay, like that. So when I add those two, I will get 20 times 10 to the power of 4 plus minus 2 is the same as 4 minus 2. I'll get a 2. Now, having that, this is not the final form. In standard form, our number should be less than 10. So I'll add a plus 1 to have my comma there. So I'll add plus 1 there. So I'll have, at the end of the day, the final answer is 2 times 10 to the power of 3. Okay, this is the final answer. Let's look at the divisions part. Part B, A over B. This is the same as 4 times 10 to the power of 4 divided by 5 times 10 to the power of minus 2. Okay, so in other words, I can divide the A's together, these ones together, and also these ones together. So let's divide. So I have 4 over 5 times 10 to the power of, since these are dividing and they have the same base, I can say 10 to the power of 4 minus 2 because they are dividing. Okay, having that, I can now write and have 4 divided by 5 is 0.8 times 10 to the power of 4 minus 2, we get a 6 there. Because I've got a comma here and it's going to go that side, it means I'm going to subtract 1 there. I'm going to subtract minus 1 there. So my final answer becomes 8 times 10 to the power of 5. Okay, that's the final answer there. This is the final answer. Let's go to the last question. The last question was saying convert that number to base 6. So what we do to go from base 2 to go to straight to base 6 is not possible. You go via base 10, then you go to base 6. Okay, so let's go first to base 10. So 101 base 2 to base 10 is equal to, we say, the first number 2 to the power raised to the power of 2 to the power of 0, second to the power of 1, the power of 2, power of 3. Okay, like that. So at the end of the day, I'll write, if I'm to write, I'll have 1 times 2 to the power of 3 plus, let's have our brackets, 0 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 2 to the power of plus, okay, sorry, there, that's 1 times 2 to the power of 0. That's the last part there. And if we are to write first one, I've got 2 to the power of 3. Okay, so the first one, I've got 2 to the power of 3. 2 to the power of 3 is that's 2 times 2, we get 4 times 2, we get 8. Okay, so I'll have an 8 here plus a 0 plus a 0 plus 1. So to base 10 is equals to 9. So it's like that. Now that I have it in base 10, I can now write it in base 6. Base 6 divide by 6 this number. We simply divide this number by 6. So let me do that, dividing by 6. So I'll have 9 divided by 6. Okay, writing the remainder, 6 into 9, I've got 1 remainder. What are the remainder? 3 there. Okay, 6 into 1 is 0, remainder 1. So taking my number from bottom going up, it means in base 6, our number becomes 13 base 6. So this is the final answer that we are looking for. Let's go on to the next part of the question. Okay, this one is saying add 1, 2, 2, 2, base 5 and base 4. We cannot really add these ones directly. Basically, unless if they were in the same base, we were going to add it directly. I'll show you in another video. So for this one, we can change either one of these. Let me change this one to base 5. Okay, let's do that. So first of all, we change it to base 10, then to base 5. Okay, let's do that. So it's gonna be a long process. So 132 base 4. So I say 4 to the power of 0, 4 to the power of 1, 4 to the power of 2. Okay, it's going to be 1 times 4 to the power of 2 plus 3. Sorry, that's 3 now. 3 times 4 to the power of 1 plus 2 times 4 to the power of 0, like that. Okay, let's add. What do we get? 4 to the power of 2, we get 16, plus 3 times 4, we get 12, plus 2 times 4 to the power of 0, we get a 2 there. So we are going to have 16 plus 14 there, we get a 30. 2. Okay, so we get a 30 there. So this is our number in base 10. Now we want to go to base 5. Base 5 is going to be, we divide by 5 there. 30 divided by 5. 5 into 30. What do we get? 5 in 30 divided by 5, we get a 6. 6, remainder is 0. Then 5 into 6, 1, remainder is 1. 5 into 1, 0, remainder 1. So taking our number from bottom going up, we get 110. This now in base 5. Okay, now we can add 110 to 1, 2, 3, 4 there. Let's do that. Okay, let me rub off this and do. Okay, so that was a long process. We go via base 10, then base. Okay, let's write. So we are adding 1, 2, 3, 4, base 5, adding 1, 1, 0, base 5. Okay, so I'm writing deliberately like this. Now let's add, please. This is how you add when they are in the same base. 4 plus 0, we get a 4. We write it as it is. 3 plus 1, we get a 4. We write it as it is. 2 plus 1, we get a 3. We write it like that. Then 1, we get it like that. So our answer becomes, if we are to add, it becomes that, okay, in base 5. So this is our base here. But if we are going to have, for example, I just want to explain something. If we had F1 here, it was going to be different. We're going to say 4 plus 1, instead of writing a 5 here, would write a 0. I'll show you in the next video. Otherwise, the answer for this one that I 1, 3, 4, 4 base 5. Okay, that's our answer there. Let's look at the last question, number 8. We are given the length of a side of a square. So let me draw the square. Square has got sides which are similar, side which are equal, and these are 7, 7, 7. Okay, so these are 7 centimeters. So the first part of the question is asking, write down the upper limit and lower limit. So upper limit, part A, upper limit becomes 7.4. Okay, because if I round off this one, I will get 7. I'll get 7. The lower limit becomes 6.5. If I round off this one, because of 5, I will get a 7. So these are the numbers that we are going to use. Then the second part of the question is saying calculate the least possible perimeter of the square. So we are going to use the lower limit there. Okay, our perimeter is equal to, perimeter of a square is equal to side plus side plus side plus side. So it's going to be 6.5 plus 6.5 plus 6.5 plus 6.5. What do we get? If we add those, let's add 6.5 plus 6.5 plus 6.5 plus 6.5. I'm getting 26. So our perimeter is 26 centimeters. Okay, even if we're going to calculate the area, you could use that. Okay, otherwise, bye bye guys. Let's meet in the next revision. Bye bye.